In this video, I'm going to be going through that Chapter 9, Test 1, Solving Quadratic Equations extra review, the backside. So for this one, I'm going to use square root method because it has that set of parentheses squared. Okay, so I'm going to use square root method. First thing I need to do is isolate this set of parentheses. So I'm going to subtract 12 from both sides. I get 1/2 times x plus 1 squared equals 44. I mean, not 44, I'm sorry, 42. Then to get rid of this 1/2, this fractional coefficient, I'm going to multiply by the reciprocal, which is 2. So I get x plus 1 squared is equal to 84. Now that I have that set of parentheses squared isolated, I'm going to take the square root of both sides. The square root of x plus 1 squared is x plus 1. The square root of 84 is positive or negative 9.17. Then I'm going to solve each of those. X plus 1 is equal to positive 9.17, and x plus 1 is equal to negative 9.17. So I get 8.17 and negative 10.17. For the next problem, I'm going to use square root method on this one as well. And the reason I'm going to use square root method is because we have a quadratic term and a constant, but we're missing that middle bx linear term. So I'm going to isolate the x squared by adding 48 to both sides. Then I'm going to divide both sides by 3, and I get x squared is equal to 16. Now that the x squared is isolated, I'm going to take the square root of both sides. The square root of 16 is positive or negative 4. Since I got a whole number answer here and no decimals, that means my original equation was factorable. So you could have done factoring method on this one as well, and you still should have gotten the same answers of positive 4 and negative 4. For the next one, I have to first put in the correct format, so I need to move the x and the 1 over by subtracting them. So if I subtract the x over, I have minus x. If I subtract the 1 over, I'll have minus 1 equals 0. Like I was saying on the front page here, if I have a trinomial on the left-hand side and a is not equal to 1, I'm going to do quadratic formula. Okay, so I would suggest anytime you have a trinomial, a is not 1, just go ahead and do quadratic formula. A is 3, B is negative 1, C is not positive 1, C is also negative 1. So I'm going to find my discriminant first, b squared minus 4ac. So b squared minus 4ac would be negative 1 squared minus 4 times 3 times negative 1. Negative 1 squared would be 1. Negative 4 times 3 would be negative 12 times negative 1 would be positive 12. So this is 13. So my discriminant is 13. So x is equal to negative b is negative 1. Plus or minus the square root of 13, which I found above, all over 2 times a, which is 3. So I'm going to clean this up a bit. Minus the negative 1 would be 1. Plus or minus the square root of 13, which is 3.61, all over 6. So I have 1 plus 3.61 divided by 6, and I have 1 minus 3.61 divided by 6. And when you solve those in your calculator, you should get 0.77 and negative 0.43. Okay, for the next one, first thing I have to do is get in the correct format. So I'm going to add 8 to both sides. So I get x squared plus 10x plus 8 is equal to 0. All right, I'm going to look to see if it's factorable. This is not factorable. There's no numbers that multiply to be 8 and also add to be 10, so I can't factor it. I can't do square root method because it's not missing the b term, the bx term. Okay, so I can't factor, I can't do square root method, so I'm left with either completing the square or quadratic formula. I'm going to go ahead and just do quadratic formula because I think that's easier. but if you want, you could do completing the square. So A is 1, B is 10, and C is 8. So I'm going to find the discriminant. B squared would be 10 squared minus 4 times A, which is 1, times C, which is 8. So I have 100. Negative 4 times 1 times 8 would be minus 32. So that's 68. So I'm going to finish my quadratic formula. X is equal to negative B, which is negative 10, plus or minus the square root of 68, all over 2A, which is 1. So this is negative 10 plus or minus 8.25, all over 2. Kind of running out of room here, I apologize. Negative 10 plus 8.25 divided by 2, and negative 10 minus 8.25 divided by 2. So your answers for that one should be negative 0.88 and negative 9.12. For number 11, I'm going to use square root method because just like the one up above on number 7, this has that set of parentheses squared. So I'm going to isolate that by dividing both sides by 3. X minus 5 squared is equal to 4. I'm going to take the square root of both sides. X minus 5 squared, taking the square root of that, gives me x minus 5. The square root of 4 is positive or negative 2. I'm going to solve those two equations. X minus 5 equals positive 2. X minus 5 equals negative 2. So x is 7 and 3. Number 12 is nicely formatted for us. We can just do factoring here because it's already in factored form. So I'm just going to set each of those factors equal to 0. And solve each of them. So I'll subtract 3 from both sides. Divide both sides by 7. So I get negative 3/7. And for this one, I'll add 2 to both sides. Divide both sides by 5, and so I get 2/5. Okay, for number 13, it's set equal to 0, so that's a good start. Right off the bat, I notice I'm gonna do square root method, and the reason I say that is because it's missing that linear bx middle term here. We have a quadratic and a constant, but we're missing that middle term. You could do factoring method for this one as well. I know that will work out, but I'm going to choose to do square root method instead. So I add 81 to both sides. Then I'm going to divide both sides by 4. Now that I have the x squared isolated, I'm going to take the square root of both sides. The square root of a positive real number is positive or negative. And then for this, you're going to take the square root of each piece. So you're going to take the square root of 81, which is 9. And then the square root of 4, which is 2. So it's positive or negative 9/2. For the next one, I'm going to do square root method for this one as well. Because again, I have a quadratic term, I have a constant and a constant, but there's no linear term. So I'm going to isolate the x squared by adding 1 to both sides. To get rid of this fraction of 1/5, I'm going to multiply by 5. So x squared is equal to 40. Now that the x squared is isolated, I'm going to take the square root of both sides. So x is equal to positive or negative 6.32. For the last problem here, I need to move the 2 over so that it's in the correct format. So I have 3x squared plus x minus 2 equals 0. Okay, so now it's in the correct format. I'm going to go ahead and do quadratic formula for this. I know you could do factoring, but since a is greater than 1, you'd have to do split the middle, which would be a little bit of work here, which actually would be probably about the same amount as quadratic formula. So if you want, you can factor this and use split the middle. But like I've been saying throughout the video, if I have a trinomial and a is not 1, I'm just going to go ahead and do quadratic formula. Okay, it makes it easier for me to remember, okay, if a is not 1, just go straight into quadratic formula. But again, you could factor with split the middle there. So I'm going to do the discriminant, b squared minus 4ac. B squared would be 1 squared minus 4 times a, which is 3, times c, which is negative 2. 1 squared is 1. This would be 12 times 2, which would be 24. So I would have 25. So for my formula here, I would have x equals negative b plus or minus the square root of 25 all over 2a. That comes out nicely. The square root of 25 is 5. Now, the reason I knew it was factorable to begin with is because, well, I guess I didn't know it to begin with necessarily. I just knew because I had a key, I guess. But really how I know that it's factorable now for sure is that once I get my discriminant, if the discriminant is a perfect number and this happens where it comes out nicely, this means that your original equation was factorable. So you could have factored it if you wanted to. So now I'm going to break it apart. I have negative 1 plus 5 divided by 6 and negative 1 minus 5 divided by 6. So this would be 4 over 6, which would be 2/3. This would be negative 6 over 6, which is negative 1. So x would equal negative 1 and 2/3. All right, you made it to the end of the video, so please reach out if you have any remaining questions.